Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts use equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities. Welcome to the Spirit of Discovery cruise ship, which will take you on an unforgettable sea voyage around the Canary Islands. The azure, endless ocean, delicious food, the highest service, premium cabins, and a terrible nightmare that you will probably remember for the rest of your life. This is exactly how one luxury trip of the Saga Cruises Company ended last year. Instead of relaxing during the cruise, passengers felt fear and horror, and even had health problems. And that's why. On October 24th, the Spirit of Discovery liner started a 2-week cruise around the Canary Islands. There were about 1,500 people on board. About 1,000 were passengers, and the rest were crew members. The first week went great, but then the liner encountered a serious problem called nature. There were strong winds and big waves. The captain decided to return to the UK ahead of time, but the decision was made too late. The ship was caught in a severe storm in the Bay of Biscay. A powerful wind with a force of 11 points hit the vessel. To make it easier for you to understand, the 11-point wind is able to tear out trees together with roots, destroy residential buildings, and plunge entire cities into chaos. Such a storm is rare, but Spirit of Discovery was unlucky enough to get into its epicenter. 11 points is the penultimate place on the Beaufort scale, which determines the wind rating. The most powerful storm has 12 points, and this is a hurricane. The wind reached a speed of 65 miles per hour, which is about the same as the average speed of a car on a highway. Not only did it push the Spirit of Discovery, but it also raised huge waves 25 feet high. Just imagine a wall of water the height of a 3-story building collapsing on a lone ocean liner. At that moment, the captain sent a message to all the passengers through the cabin speakers so that no one left their place. And his voice sounded worried enough. All the passengers had to lie down and hold on tight. According to the witnesses' words, the ship remained caught in the storm for about 15 hours. They held on with all their might so as not to crash into the walls and floor. All this time, tables were flying around the ship, dishes were breaking, furniture was moving all over the cabins. The waves smashed windows, partitions, and doors. Some people were knocked down because they couldn't hold on for so long. The storm hurled the passengers from ceiling to floor, from wall to wall. The ship's crew turned the dining room into a medical area to provide assistance to those who had been hurt. Despite the difficult and terrible conditions, the ship's team did a great job. They regularly informed passengers about the current situation and tried to calm everyone down. There was no panic and chaos on board. When the storm finally ended, the ship continued its journey and finally reached land, where medics urgently evacuated 8 passengers to the hospital. One of them was never able to survive this storm. It's good the ship didn't meet a rogue wave during the storm. This is a natural phenomenon that can appear during a storm and even in still water. It's a giant wave with a height of 60 feet. Like a 6-story house, it collapses onto a ship with incredible speed and capsizes it. And then the wave suddenly disappears. This is no joke. A similar wave has been recorded in the Gulf Stream off of Charleston, South Carolina. It's scary to get in its way. Now, let's go back to the past to remember one of the most terrible maritime tragedies. No, we're not talking about the Titanic. We'll talk about the Greek liner Laconia, which set sail from the English port of Southampton on December 19, 1963, with more than 600 people on board. However, just 3 days later, a terrible tragedy happened to the ship in the boundless waters of the Atlantic. At 11 p.m., in the barbershop hall, an electrical malfunction occurred. The problem led to a fire, which quickly spread to other rooms. The crew couldn't cope with it, since the fire was spreading too fast. The ship's team turned on the fire alarm, but there was no command to leave the vessel. Only 2 hours later, the captain ordered the passengers to evacuate. All this time, people were either relaxing in their cabins or enjoying a party in the ballroom. The crew was probably trying to put out the fire without causing panic. However, when the situation became critical, the evacuation began. People panicked and ran to the lifeboats, but many didn't manage to get inside. One of them was John Morris. He survived this catastrophe and shared his memories of how he put his family in a lifeboat while he stayed on board the ship. He didn't even have a life jacket. Since there was nowhere to go, the ship's crew opened a bar so that people could relax a little. However, at that moment, boilers began to explode inside the ship, and it became clear the vessel wouldn't stay afloat for too long. John Morris decided to jump into the water right in his tuxedo. As soon as he was overboard, he grabbed onto a piece of wooden deck cargo and swam as far away from the ship as he could. The giant liner could sink at any moment, and when such a huge object goes down to the seabed, it forms a water funnel that pulls along everything around. Rescuers arrived at the scene sometime later. Fortunately, John Morris's pregnant wife and young son were alive, but his mother-in-law unfortunately didn't survive the disaster, like many other people that day. Of course, after this incident, the Greek Ministry of Merchant Marine initiated a thorough investigation. For 2 years, they collected information from passengers and the captain, studied the technical characteristics of the ship, and eventually came to certain conclusions. According to them, the ship's crew gave the evacuation order too late. Not all passengers were able to get into lifeboats, but half of those boats remained on board because of the chaos that prevailed during the evacuation. Several officers of the liner were accused of negligence, but the captain and his first mate received the most criticism. As for John Morris, He stated that he felt himself under protection that day. Another unusual story happened on a cruise ship relatively recently. Spoiler alert, the ship didn't sink, there was no evacuation, and the weather was good. However, for many passengers, this journey became a real challenge. Imagine that you've been working for a long time and saving up money to go on your dream trip on the Celebrity Mercury cruise ship in the Caribbean. You arrive in South Carolina, from where the ship begins its journey. You get on board, looking forward to a week's rest. At first, everything is fine. People are having fun, chefs are cooking delicious dishes, and beautiful daytime landscapes turn into night parties. But then suddenly, many passengers start throwing up. Someone is in a hurry to go to the toilet, and someone stays and vomits right in the halls. The cruise turns into chaos. More and more people feel terrible because of unknown poisoning. You also visited the restaurant and eaten seafood, but fortunately, the disease has avoided you, which can't be said for more than 400 other passengers. Almost every 1 in 4 people on board face gastrointestinal problems. There were almost 2,000 people, and a quarter of them are in bad condition. Crew members do endless cleaning. They wash the deck, give people nausea pills, and ask them not to leave the cabin till the illness passes. The captain sends several samples ashore to determine what caused the poisoning. Unfortunately, the cruise is already ruined, and all the passengers have unpleasant memories. So the company organizing the trip issues certificates that can be used on future cruises. It's not the most pleasant experience, but it's still better than nothing. Now, imagine if, instead of just feeling sick, people got infected with some kind of bacterium that would turn them into zombies. It would be much more exciting and scary. Now, do you think you could survive on such a ship full of zombies? And how would you do that? Tell me about it in the comments.
There's something really bizarre going on at these 12 points scattered across the Earth. The vile vortices, as they're called, are these creepy spots over the Tropic of Cancer, the Tropic of Capricorn, and the North and South Poles, where weird forces seem to take over. You've probably heard of the most famous one, the Bermuda Triangle. It's believed that more than 50 ships and 20 airplanes have mysteriously disappeared in this area, which is located between Florida, Bermuda, and Puerto Rico. But what most people don't realize is that the Bermuda Triangle actually has 11 siblings, and these other spots can be even more terrifying. Let's start with Mohenjo-Daro. This was a thriving city located in what is now Pakistan. Built around 2500 before the Common Era, this urban center was once home to about 40,000 people. But then, suddenly, people abandoned it by the year 1700 before the Common Era. In the 1940s, an archaeologist discovered 39 human skeletons at the site, which fueled the theory that the city was invaded by some other civilization at some point. But honestly, it's hard to confirm that, since archaeology doesn't really explain the city's sudden destruction or the disappearance of its people. It's led to a bunch of bizarre theories. One of them talks about an ancient extraterrestrial race that might have lived there, and a malevolent wind that swept through the city. Another ancient city with a similar mystery is the Great Zimbabwe. Its construction began in the 11th century, and at its peak it housed up to 18,000 people. But for reasons we'll probably never fully understand, it was abandoned in the 15th century. Archaeologists were really interested in this place, and that's when things got even weirder. They found 8 of these birds, now called the Zimbabwe birds. These soapstone sculptures were found sitting on stone columns that were over 90 centimeters tall. Nothing like them has ever been found anywhere else, and their meaning is still a total mystery. Some think each bird represents a new king, but other theories suggest they were ancient animals very dear to the people who lived there. Adding to the mystery, local legends talk about a strange, short man who's sometimes seen wandering around, but he always disappears before anyone can get close. Then there's Easter Island, another one of the 12 vile vortices. It's located in the eastern Pacific Ocean, and it's famous for its nearly 1,000 enormous statues called moai. We still don't know what they mean, or how they were made. Some of them are almost 30 feet tall and weigh as much as 80 tons. Today, it wouldn't be that tough to move and carve these statues, but we're talking about a period between the years 1100 and 1680. So nobody really knows how they did it. Some specialists believe these statues were carried across the island, while others think they were pushed on log rollers. But the most bizarre theories suggest extraterrestrials were involved. Algeria is another land rich in ancient mysteries. And one of the most fascinating is something called the Jedars. These are 13 monuments with square stone bases and angular mounds, built between the 4th and 7th centuries. But the weird part is, no one knows their purpose. One of them had an inscription in Latin, but it was so worn down that the message was nearly impossible to read. The best guess so far is that these monuments were probably tombs for royalty, although no one knows exactly who was supposed to be buried there. What we do know is that there are many myths related to strange disappearances in the region. The next mysterious spot is located south of Tokyo in the Pacific Ocean, and it's called the Dragon's Triangle. Does that name ring a bell? Yep. Just like the Bermuda Triangle, this area is known for strange disappearances of airplanes and ships. One of the most chilling stories dates back to 1945, when a plane allegedly vanished. The pilot supposedly sent a radio transmission right before the aircraft disappeared, claiming that something strange was happening in the sky, like it was opening up or something. While this story is definitely eerie, the truth behind it and many other Dragon's Triangle legends is still up for debate. If you type Hamakulia volcano into Google Earth, you'll find it located in Hawaii's Ring of Fire. But this place is so shrouded in mystery that it's hard to find much information about it. Some legends speak of unusual electrical energy being detected in the area, and there's even a story about an eyewitness who claimed to see a plane flying over it totally disappear from the radar. Another eerie spot is the South Atlantic Anomaly, which is an area on Earth where natural radiation flows out of control. While this doesn't affect our daily lives on the surface, it has a pretty big impact on Earth's atmosphere. The radiation there is so intense that it can knock out the onboard computers of spacecraft and interfere with the data collected by satellites passing through the area. To deal with this, specialists had to add an additional shield to the International Space Station. The South Atlantic Anomaly is also linked to a weird event that astronauts experience called cosmic ray visual phenomena. They've reported seeing random flashes of light or shooting stars out there in space, but it's all just some kind of illusion. From wild radiation to strange seismic activity. The Wharton Basin in the Indian Ocean is a place known for unusual tectonic events. In April of 2012, a massive earthquake measuring magnitude 8.6 hit the region. This was considered the largest intraplate earthquake ever recorded, meaning it happened within a tectonic plate rather than at its boundary. This caught the attention of scientists, who now speculate that the region might be forming a new boundary between the Australian and Indian plates. But for now, this is all still one big mystery. Now let's head to the Pacific Ocean. More specifically, to the New Hebrides Trench. This submarine trench is about 750 miles long and 45 miles wide. It formed when the Australian plate slid under the New Hebrides plate. There's no doubt that this is one of the creepiest and deepest spots in the ocean. The danger isn't just down in the deep sea either, as this trench has been connected to several earthquakes that affected New Caledonia and Vanuatu. This area also has some strange features. For example, when scientists explored it, they didn't find a single grenadier fish down there. This type of fish is one of the most common deep-sea creatures you would expect to see in trenches around the Pacific. So why aren't they around the New Hebrides Trench? Maybe they know something we don't. The two remaining vile vortices are the North and South Poles. These two are on the opposite ends of the planet, but they share one thing in common: strange disappearances. One of the most famous stories from the North Pole happened in 1897. 3 brave explorers set out on a journey to reach the North Pole using a hot air balloon. But they never completed their mission. Their mysterious disappearance remains one of the most intriguing, unsolved mysteries in the history of Arctic exploration. The South Pole is also known for similar mysteries. It's believed that hundreds of people may be buried beneath the snow and ice of the coldest continent on Earth. Even with all the advancements in technology and knowledge, the South Pole can still be extremely dangerous for anyone who ventures there. The temperatures can drop to almost minus 130 degrees Fahrenheit, and the winds can get up to 200 miles per hour. And that's definitely enough reason to stay away. Now that you're familiar with the 12 vile vortices, let me tell you something even stranger. If you look at a map, you'll see that these places are arranged in a way that looks pretty similar across the globe. Here's the weird part. If you connect these spots where unexplained events have occurred, you actually form the geometric shape of an icosahedron. This could be just a huge coincidence, but the fact that these mystery spots align with this shape makes them even more intriguing.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tejon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis, but there's something that can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas Fault Line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate, and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas Fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas Fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas Fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed, but Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Euclid wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got in a terrible storm and saw several waves over 98 feet tall. It's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Unintentional. Over a century later, a cargo ship, the MS München, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppler on New Year's Day. It was twice larger than the wave surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. It can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happen not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are 2 main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger, which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas, when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a cross wave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the cross wave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega-earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the time. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So, what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the US was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely, and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter, although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle, near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the derecho chooses a point somewhere and simply runs to it, like a very motivated marathon runner. If we compare a derecho to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So a derecho is kind of like a small, average level 1 to 2 tornado. Usually its speed is within the range of 73 to 113 miles per hour. And in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a derecho if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to derechos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, scientists don't have an exact explanation. But although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, the sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, Seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, People in different parts of the world woke up in the middle of the night because it was so light outside, they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes. It was June 1928 when Mr. Keller almost lost his life in a terrifying natural disaster. He was outside with his family when he noticed an umbrella-shaped cloud that seemed to be approaching them. It gave him a sense of foreboding. A tornado was probably forming there. Indeed, in no time, 3 huge funnel clouds were dashing their way. After rushing his family into the storm cellar, Keller decided to have another look, and what he saw both terrified and mesmerized him. The twister was directly overhead, but inside the swirling cloud, everything was eerily still. The man could feel a strong, grassy smell. He had trouble breathing. He looked up and saw a circular opening right overhead. It was around 50 to 100 feet across and around half a mile high. Keller could clearly see the walls of the rotating cloud. Constant bursts of lightning zigzagged from side to side non-stop, illuminating this horror movie scene. The man could also see many smaller tornadoes forming and breaking free. A deafening, hissing noise was overwhelming. And the next moment, the tornado skipped over Keller's house and smashed the home of his neighbors. Mr. Keller wasn't the only person to see the tornado from the inside and live to tell the tale. But other survivors didn't end up as unscathed. It seemed to be a regular day when Chris Tuving from Dallas, Texas got to the Little Caesars in 2019. They had run out of pizzas, so he decided to wait. Well, it was a grave mistake. A powerful tornado hit the shopping mall where he was staying and pulled him out of the building. Chris managed to find a support column and held on for dear life. But no muscle strength could compare to the terrifying power of the tornado. Tuving was lifted into the air and thrown into a truck parked in front of the restaurant. He tried to hold on to the hood, but there was nothing to grab. In the end, he managed to hold on to the rim of the left front tire and stayed there until the whole nightmare stopped. The tornado Chris survived had sustained winds of 140 miles per hour and was 13 football fields wide at the base. Eric Simmons recalled taking cover from a tornado in May 2019 by climbing into his truck. Once inside, he looked out of his right windshield and saw vines growing along the fence. They were moving around in a bizarre way that confused the man. And then it all started. Suddenly, everything Eric could see was wind and pitch-black darkness. Then, a section of a roof flew over him and shredded apart mid-air. The truck's back windshield shattered, showering the man with shards of glass. A tree in front of him was lifted into the air like a twig, and the fence blew over the top of the truck. Simmons could feel the back of the vehicle lifting. He could see the power lines exploding right in front of his eyes. Even though the visibility was terrible, he could still see the flashes. It all lasted around 45 seconds, but to him, an eternity seemed to have passed. When the coast grew clear, Eric got out of the car, but he could barely walk after the shock he had lived through. He couldn't speak. It was one of the most horrifying and traumatic experiences of his life. According to the man, the real reason why he was so terrified was because he had no training, no warning, and no defense against whatever was coming. Later, he found out that the tornado had almost taken his life at a speed of 86 to 110 miles per hour and was around 75 to 100 yards across. A tornado is a rotating column of air that touches the ground. Sometimes it's connected to the base of a thunderstorm. The wind speeds inside tornadoes can top hundreds of miles an hour. No wonder they have enormously devastating potential, picking up objects, unrooting trees, destroying buildings, you name it. The problem with escaping a tornado is that it's not always easy to see. The wind, however severe it is invisible. The first sign of an approaching tornado might be the infamous rumble resembling the noise a moving freight train produces. There are also some other sounds indicating that a tornado is coming, but the human ear can't perceive those. When you spot that classic tornado cone, it means it has already developed a condensation funnel made of water, dust, and debris. The most destructive tornadoes are born from rotating thunderstorms, called supercells. Luckily, those are something meteorologists can actually notice because such storms have a well-defined appearance on radars. Experts believe that the difference in the temperature of such a storm can determine how likely a tornado is to form. And still, there's a lot we don't know about this process. For example, the question about why and where tornadoes are most likely to appear remains unanswered. The strength of tornadoes is measured with the enhanced Fujita scale. The rating goes from 0 to 5, considering the damage caused by a tornado and its wind speeds, where EF0 is the weakest tornado and EF5 is a tornado I hope you will never ever come across. The EF scale rounds off at wind speeds of 318 miles per hour, with strong frame houses being lifted off foundations and carried long distances to be eventually broken into pieces. Cars fly through the air for more than 328 feet away, and steel-reinforced structures are left badly damaged. Despite this terrifying power and ferocity of tornadoes, authorities report that even the worst of them have a 99% survival rate. But it doesn't mean that you shouldn't take all possible precautions to avoid ending up inside one. Stay away from doors and windows. Move to an interior room if possible, and use pillows, blankets, and mattresses to protect yourself from flying debris. If stranded outside during a tornado, crawl into a ditch and cover yourself, protecting the head. Now there's another twister that is as scary as a tornado, but this one forms in the water. Whirlpools appear when fast-flowing water crashes into an obstacle or another current. The water starts swirling in a downward spiral, creating a vortex that can pull objects, animals, and even small boats that happen to be nearby to the bottom. One more way for a whirlpool to form is the sudden appearance of a sinkhole created by a collapsed cave, for example. This makes water flood the hollow structure and creates a whirlpool similar to the one you see when you pull the plug out of a bath filled with water. While some whirlpools are small and brief, others can reach enormous sizes and be driven by constant currents. The most dangerous of them are maelstroms. If you get into a whirlpool like that, your chances to get back to the surface are slim. The incessant movement of the water and its pulling power can leave you disoriented and stuck without air. That's what happened to Stuart Falstone when he got trapped in a whirlpool. His first instinct was to swim out of it, but this idea proved to be hopeless. The footage filmed by the cameraman attached to his helmet later showed that the man had been underwater for almost 3.5 minutes. He had probably been dragged all the way down to the riverbed. There, the pull of the twister lessened a bit and finally released its hold. The guy was lucky to get spotted face down in the water and pulled to the surface by a kayaker. The depth a whirlpool can pull you down to can vary. It depends on its power and size. Sadly, not everyone who got trapped in a whirlpool survived and got out again. In different ways in which whirlpools form means that sometimes they can appear out of the blue. You can't predict this process and get no warning. So the best way to stay safe is to wear your life jacket at all times when in the water. If you get pulled into a whirlpool, try not to move in the same direction as the water flow. Aim for the outer edge rather than the center of the twister. If you're lucky, the whirlpool might throw you back up. There have been precedents. And if you come over a whirlpool in a boat or kayak, do your best to stop the boat from filling with water. If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain. And that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters. But areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern U.S. and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
Check this out. There's a giant tornado heading towards you, and it's so fast. These twisters can move at crazy speeds of more than 250 miles per hour. Plus, they can carve a pathway 50 miles long and a mile wide. Sometimes you can see them coming clearly, while in some cases, low-hanging clouds or rain can hide them, so they sneak up on you and you don't even see them. And in most cases, a tornado can develop so fast that no one can even warn you in time if it's already too close. And now, this insane storm is really close. Maybe you have a couple of minutes to get somewhere safe. Do you have a basement? Go hide. Or maybe, I know this is a crazy idea, but what do you think about going inside a tornado to check what it would be like? Now, some tornadoes appear as rope-like swirls, while others have wide clouds in the shape of a funnel. And here's the second one, right before you. Look at these whirling winds born in a thunderstorm. They extend down from it to the ground. Many times, hail joins the party too. The U.S. itself has something like 1,000 tornadoes per year. Texas holds the record with about 120 tornadoes per year, a record not to be proud of. But you'll generally see most twisters in Tornado Alley, which is a stretch of land in the midwestern part of the U.S. They develop when warm, moist air coming from Mexico meets cool, dry air from Canada. These two clash and turn into a powerful storm that at some point can spawn tornadoes. And you'll see most tornadoes there between April and June, though lately some have come even in December. They can range from a regular dust storm to an incredibly powerful force that can carry away cars, large trees, and even houses. But this is a unique chance. You've never been this close, right? Plus, it's a gigantic one. You don't often get to see such a big one. Okay, ready then? It's getting closer. You feel the wind getting stronger while tossing dirt and debris in your face. You close your eyes and whoosh! You're inside, and it's crazy. Vicious winds are hurling and spinning you around. They're lifting you up at the same time. Feeling dizzy? Feeling like Dorothy from The Wizard of Oz? Now may be a good time to check what's really happening to you, while inside swirling with winds and… oh wait, is that your neighbor's motorcycle spinning together with you? Hope it'll stay that far away. Now, let's take a moment to catch up. Being in the middle of a raging tornado is actually something you might survive. But I won't lie to you, it won't be easy. The first thing you'd sense would likely be the temperature changes. Inside this crazy twister, it can be 36 degrees colder than outside of it. That's because the center of the tornado funnel spins all the time. All that funneling makes the inside of the vortex way colder, and it makes the air way thinner than you used to. The air would be 20% less dense than, for example, what you would find at high altitudes. Now, I hope you're not planning to stay there for too long. Disclaimer here, the atmospheric pressure inside this swirling vortex is so low that your lungs won't be able to extract enough oxygen. Now, to give you a perspective of all this, breathing inside a tornado is like trying to get some air at an altitude of 26,000 feet. That's a pro level, similar to climbing Everest. So yeah, you'll need some help just to be able to take a regular breath. In short, you'll probably pass out after only a couple of minutes. But don't worry, I brought you this special mask, so breathing is not a problem anymore. Hey, did you notice how smooth the airflow from the inside is? Some storm watchers ended up inside a tornado. Later, they said it all looked so chaotic with all those raging clouds and wind swirling around. But from the inside, the air is surprisingly smooth. But that doesn't mean you'll get a peaceful ride because of it. And it's not a solo party in that thing. The neighbor's motorcycle is not the only thing you'll see there. Wood, bricks, glass, maybe even cars, cows, motorhomes, bricks, roofs, and other big objects. You'd be pretty lucky if nothing crashes into you in all that chaos. With all that debris that's swirling at, for instance, 310 miles per hour, you can hardly avoid it. But let's just say a miracle happens and you got through it. Now you're really dizzy, and you're just wondering when all of this is going to be over and if you're even going to be able to come out of this gigantic tornado. Well, the tornado will eventually slow down. It happens because cool air enters the twister. Just because things are settling down, it doesn't mean you can relax. Well, your stomach can, since all that crazy swirling is done, but the tornado will drop you from whatever height you're on when it stops. If you're somewhere in the countryside, there might be some soft bale of hay to break your fall. Oh wait, we're talking about a twister that's probably more than 45,000 feet tall, so that won't work. I hope you brought your parachute, because now would be a good time to pop it. Nope. Hey, don't worry, I'm all about happy endings, so I'll help you out. Here you go. And now you're slowing down, enjoying the view, if you even see anything around you from all that dizziness. How come there are clear sunlit skies from your left, you may wonder? It's not unusual. Tornadoes often form near the edge of a thunderstorm. It's like a border between two different worlds. And it wasn't even windy. Plus the air was very still before it hit, right? Well, that's common too. Okay, I think you know this kind of scenario is impossible in reality. So it would be best to find a safe spot quickly if a tornado is close by. Use your underground shelter first. And if you don't have one, your basement could be the next best choice. Prepare ahead of time with a battery-operated TV or radio, together with fresh batteries, or a device with internet to be able to hear the latest updates on the tornado. Include some non-perishable food, water, and other essentials prepared too. As it turns out, some people really were picked up by tornadoes, and they managed to go through it. A tornado actually dropped them a few hundred feet away without a scratch. Hey, I'd say that's a whole lot of bother just to save some bucks on Uber. But you can't have a guarantee you'll be safe or where you'll end up. It would be incredibly hard to get out of one of those big and fierce ones, though, like supercells. They fall into the category of the strongest type of storms, mostly thunderstorms. And imagine falling into waterspouts. Those could be fine, though, at least the beginning, because they're weak and they form over warm water. So they could be like a part of your spa day, at least until they move inland and turn into a real tornado. Now, dust devils wouldn't be that pleasant. They're not that big, but we're talking about columns of air that rotate at large speeds. And you can easily see them because of all that dirt and dust they pick up, which is why you need glasses for that. Whoops, wait, I forgot that, so I can't help you this time. But if it makes you feel any better, they're not associated with thunderstorms. Don't know why that would make anyone feel better when I think about it. But if you're willing to jump into a fire tornado, I'll find you a special suit that will keep you safe while spinning through smoke, gas, and flames. I promise. Columns here are narrow and they rise vertically into the air, similar to a dust devil. Of course, the heat is crazy. And as updrafts are becoming stronger, and if there's enough dry fuel, a fire whirl is turning into a real fire tornado that extends from the ground up to the cloud, moving incredibly fast. Okay, let's stop now. I'm pretty dizzy. Uh-oh, a strong wind is blowing. Black clouds cover the sky. Thunder is rumbling and is pouring down with rain. A storm is coming, but you don't care. You're sitting in your apartment listening to music and typing something on your computer. You hear a thunderclap. Look out the window and see a heavy downpour, a tornado, and lightning flashes. You close all the windows and go back to the computer. And then, bam! It seems that lightning has struck near your house. Your laptop and all electrical appliances in the home go off. The light goes out. You get scared. At this moment, you hear a strange hissing sound. You see how, like a phantom, a round glowing ball of electricity flies into your house through a closed window. It penetrates your room, hovers in the air, waits for something, and then flies back through the walls. The lights turn on, and everything comes back to normal. You've just seen a real natural phenomenon called ball lightning, and you're fortunate to be alive after meeting it. This is a rare phenomenon. Ball lightning occurs during a thunderstorm in the form of a floating sphere. It can change color from blue to orange and yellow. It's the approximate size of a basketball, but can also be much more significant. This lightning makes a hissing sound and a pungent smell. Phew! The first records of ball lightning were made in 1638 in England. Then, a giant glowing ball flew into the church window. Since then, there have been a lot of evidence of how ball lightning got into houses and frightened people. In the 20th and 21st centuries, scientists actively investigated this phenomenon. They found out that half of the cases with ball lightning were just hallucinations caused by magnetic fields during a thunderstorm. But they couldn't wholly refute the fact of the existence of ball lightning. They agreed that this phenomenon existed, and once they even managed to record it. The phenomenon of ball lightning was caught in China. Researchers studied the behavior of thunderstorms in 2012 using video cameras and spectrometers. They saw an unusual lightning strike, after which the ball appeared. It flew horizontally about 33 feet and disappeared. The spectrometer showed that the ball consisted of silicon, iron, and calcium. If it's real, then what is its nature? There are several theories. Perhaps the ball lightning occurs as a result of a lightning strike on the ground. Oxygen and evaporated elements from the soil create a reaction in the form of a round clot of energy. This explains why the spectrometer in 2012 recorded the same calcium in the ball lightning as in the ground. Another theory says that glass can generate these balls. Atmospheric ions accumulate on the glass surface and create an electric field. Together with a lightning strike, this field turns into ball lightning. That's why there's so much evidence that the sphere flies into the building through the window. In 2016, scientists pointed out that a lightning strike on the ground created microwave radiation that can form into a plasma bubble. This floating electric plasma takes a round shape and hovers in the air for a few seconds. Earthquakes can cause ball lightning too. During ground tremors, flashes of light appear from the depths of the crust. It's like lightning that comes not from the sky, but from the ground. Some of these lights may look like floating blue spheres. In 2014, scientists studied earthquake lights and found that some rocks emit electrical discharges during seismic wave impacts. In 2006, researchers at a university in Tel Aviv created a laboratory to study ball lightning. They used microwave radiation to recreate a lightning-like electric charge. In 2018, quantum physicists made a complex synthetic magnetic field similar to ball lightning. Physicists, chemists, meteorologists, and other scientists have conducted research and laboratory experiments many times to understand the nature of this phenomenon. But so far, no one has succeeded. Other glowing balls are less dangerous, but still mysterious. In clear weather, you can see strange glowing lights away from cities, somewhere in a swampy area. Previously, when there was no electricity, people noticed these lights. They thought someone needed help. What if some guy is stuck in the swamp and shines a kerosene lamp to get seen? People went to these lights to help, but fell into the swamp, and the light either flew away or disappeared. Some records speak of several lights at once. They moved quickly and changed their colors. Many believe that these were some kind of mystical creatures that lured people into traps. But over time, scientists managed to uncover the mystery of this phenomenon. Bioluminescent fungi and algae grow in swampy places. Sometimes they glow with blue light and create the illusion of glowing lights from a distance. Also, there's a lot of plant material in the swamps: leaves, grass, mud, clay, and tree branches. These substances decompose rapidly in humid conditions and release methane. As soon as methane contacts air, it ignites. The flame flies over the swamp in the form of a burning ball. Mysterious lights appear not only in swamps. People see them in deserts or mountainous areas. Sometimes it's headlights from cars. In other cases, it's the signal lights of an airplane. But in many cases, the nature of such lights remains unknown. And now, imagine a huge ball the size of a small city. It's like a dome, covers a large area, and protects it from tornadoes and storms. This phenomenon is called the Delco weather bubble and is located in Delaware County, Pennsylvania. That's how it all started. In 1996, one of the strongest snowstorms of the 20th century hit the U.S. East Coast. It was named the Blizzard of 1996. It covered almost all of Pennsylvania, but in the small town of Delaware County, Delco for short, the weather was good. The storm raged around but didn't touch the city. Since that year, the locals have believed that an abnormal weather bubble protects their houses. However, there's no scientific evidence of the existence of this bubble. After the blizzard of 1996, there were several more storms in the area, and forecasters claimed some storms would also cover Delco. But contrary to their forecasts, the weather there was excellent. Strangely, there is no meteorological evidence of this. One of the residents decided to investigate this phenomenon seriously. He followed the weather forecasts, looked at satellite photos, and saw how the black clouds diverged around the city. It rained heavily in the neighboring towns, but not Delco. This seems like convincing proof. And the question remains, should we believe the locals? There's one scientific explanation explaining the nature of this phenomenon. Storms may weaken here thanks to the sea air that accumulates in the Delco area. The street and the city's surrounding area are filled with this humid, cold air. It creates a sort of stabilization of the atmosphere, and when intense storms from the west collide with Delco's air, they lose a significant part of their strength. And it seems as if bad weather just bypasses the city. But there's another explanation, a psychological one. All the known information about the weather bubble came from the stories of residents. They see confirmation of this phenomenon and write about it on social media. Someone said that they'd seen a tornado pass by his house. Others claimed that the bubble had saved them from a downpour. People think that it didn't affect others if there was no trouble with their house. Imagine the TV says that a storm has started in your city. You look out of the window and see a clear sky, no wind and rain. It seems to you that the bubble has saved you again. Although behind you, a few hundred feet from your backyard, a tornado is raging and tearing the roofs off of buildings. But you didn't see it and wrote to the social network that Delco has saved your city again. In this sense, the weather bubble becomes more like a virtual one, thanks to the people who write about it. Ah, a purple sunset. You must have seen one of those at least once in your life. Normally, it's nothing ominous and has to do with the way light travels. The light that the sun produces is white. When it goes through a prism, you see light waves of different colors, from red and orange to blue, green, and indigo. Light normally travels in a straight line if there's no obstacle in its way. The shorter light waves, including blues and purples, are scattered easier when they meet with those obstacles, like molecules and aerosols in the atmosphere. Because the sun is low on the horizon at sunset and sunrise, its light has to pass through more molecules that scatter the violet and blue light. The colors that your eyes pick up, then, are yellow, orange, and red. But with the right conditions, you can see the gorgeous purple sky. Sometimes purple sky appears for much scarier reasons. It can be caused by hurricanes, wildfires, or dust storms. The concentration of vapor in the air increases, and the light scatters more than usual. Dust, a setting sun, and low cloud cover all contribute to this natural show, too. The sky turns orange and red at dusk if there's still enough light. Then it gives off pink hues, which mix up with a dark blue sky above. Now, do you remember what happens when you mix pink and blue? You get the color purple. Not every hurricane makes the sky turn purple, and trying to predict if it's going to happen is like trying to forecast a rainbow. Still, people reported several major hurricanes made the skies turn purple. Now, green skies might look just as spectacular as purple ones, but they actually also scream danger. They're usually there to tell you a thunderstorm, hailstorm, or a tornado is somewhere nearby. The unique color is a result of yellow sun rays getting mixed with the blue light coming from storm clouds. So you're enjoying a nice day by the ocean with a fresh breeze in your hair, when suddenly you notice the water starts retreating from the beach at a huge speed. This is a sign for you to start running as fast and far away from the beach as you can. This most likely means that a tsunami is on the way. A quick reaction maximizes your chances of survival. Now, if you notice the sea level is rising, but it doesn't seem too extreme, it could be another sign of an approaching tsunami. It happens in 40% of cases, and the incoming water is the first tsunami wave. The next one, way larger and more dangerous, usually follows in about 10 minutes. Another thing about tsunamis is that they like to arrive with some loud sounds. People describe them as thunder, the sound of a locomotive, a helicopter, or just a loud boom. Do you see a channel of choppy water on the beach? It's in your best interest to stay away from the water. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange break in the waves, or an area with a different color than the rest of the water. Random bits of seaweed going in all directions is another rip current warning sign. If you happen to find yourself caught in a rip current, try to stay afloat, but don't try to go against the current. You'll only waste precious energy. Scream for help and try to float your way along the beach. Once you break out of the current, swim diagonally to the shore. The next time you spot conically shaped clouds in the sky, remember it's a good time to start looking for some shelter. If it just stays like that, a severe storm is on the way. But if a cloud of that shape starts spinning around, it means it's about to transform into a tornado. If you have bees nearby, they can save you from big trouble one day. These hard-working little guys get more active than usual when they feel like a storm is on the way. They speed up to collect more nectar before it hits them, and once they're done with it, they'll always come back to the hive 10 to 15 minutes before heavy rain, even when there are no obvious signs of it coming. Their secret is super sensitive hairs on the back that can pick up electrostatic buildups from storm clouds. For centuries, people have noticed that animals act weirdly a couple of days before big seismic events. Dogs can't stop barking, cows halt their milk, and toads, rats, and snakes leave their homes. It looks like animals can feel smaller initial shock waves that humans don't even notice. Scientists have tried to find some legit explanation for it and run endless tests and experiments. But so far, they're still on their way to explaining this mystery. Can you smell ozone in the air? When a thunderstorm is on the way, it's the most distinct and pungent smell you can pick up. An electrical charge of lightning sets it free from higher altitudes. The other, more pleasant smell of rain is petrichor. Rainwater wakes up molecules on plants, trees, concrete, and asphalt. Their aroma spreads all over the place. You can even feel that smell in your own mouth. All those positive ions in the air that a lightning bolt sets free gets mixed with ozone and your saliva, and that's how you get that bitter metallic taste. When lightning is about to strike, you might hear bizarre crackling, buzzing, or vibrating sounds coming from metal objects nearby. Your palms may begin to sweat, and then you can feel your hair stand on end. That's a clear call for action, and that action is to run for your life. Positive charges are going through your body trying to reach toward the negatively charged part of the storm. Trust me, you don't want these charges to meet. If you see no shelter that you can reach fast, try to make yourself smaller than the objects around you. Drop down your umbrella and stay away from wire fences, metal pipes, rails, and other metallic objects. And don't lie flat on the ground, it's likely wet, which means it's a great conductor of electricity. If you suddenly notice crevices in the asphalt next to your house, it could be a sinkhole warning sign. Inspect your house on the inside. Does that door begin to jam? Or maybe there's a gap where the walls meet the ceiling. Uneven kitchen cabinets and drawers, slanted floors, stairs that begin to slope, water leaking after every rain, and displaced moldings are all signs that a sinkhole is about to open. To find out if it's definitely a sinkhole and how dangerous it is, you gotta consult with an engineering company. If you find a sinkhole that's already there, you gotta stay away from the sinkhole area. Fence or rope it off to make it less dangerous for others. You'll need professional help to fix it. Some volcanoes scream when they're about to erupt. Small earthquakes, which often happen before, produce a hum. It's mostly non-audible to human ears, but sometimes it reaches a frequency that lets you hear it as a strange rumbling or hissing sound coming from the ground. This noise is known as a harmonic tremor. With some volcanoes, it's the sound of magma bubbles vibrating when they're going through crevices in the crust of the earth. But it's not always like this. If scientists manage to understand what exactly causes these volcanic screams, they could create a limited early warning system for volcanic eruptions. If you're out in the wild, pay attention to the water in creeks, streams, and rivers. If its level is quickly falling, even if it's raining, this might be a sign of a nearing landslide. And if you hear a faint rumbling noise or unusual sounds, like boulders knocking together, it could mean debris is on its way to you. It's a sign to head to safety immediately, like right now.
Look at this ominous dark cloud. Is it rotating? What on earth is happening here? What you see is called a supercell. It's a storm, often a thunderstorm, that contains an updraft rotating about a vertical axis. That's why they're also called rotating thunderstorms. There are actually 4 types of thunderstorms: single cell, multicell, squall line, and supercell. Out of them all, supercells are the rarest and the most severe. They're typically isolated from other thunderstorms and last for 2 to 4 hours. Supercells are very common for the Great Plains of the United States, in particular, the area known as Tornado Alley. But they can occur in other parts of the world too. For example, in Europe, Argentina, Uruguay, and southern Brazil. These storms can be any size, large and small, high or low topped. Supercells are also associated with the most severe tornadoes, even though not every supercell can create one. These storms usually produce great amounts of torrential rainfall and hail, and are accompanied by powerful winds and downbursts. Downbursts are powerful winds that come down from a thunderstorm. Once they hit the ground, they spread out very quickly. These winds are dangerous since they can cause a lot of damage. Even though they're often confused with tornadoes, downbursts are a totally different phenomenon. Let's have a look at how a downburst forms. At the beginning of a thunderstorm, there's a powerful updraft. That's why the cloud grows vertically, and hailstones and raindrops start forming inside. The storm matures, and the updraft keeps feeding the cloud with unstable, moist air. Hailstones and raindrops are now big and heavy enough to fall to the ground. But sometimes, the updraft is so strong that it suspends huge amounts of hail and rain in the upper part and the center of the storm. But let's say some dry air gets into the middle and lower parts of the storm. It can cause a downburst. When it happens, all that amount of rain and hail from the upper part of the storm dashes toward the ground, dragging along a lot of air. All this mass gains speed, and when the downburst eventually reaches the ground, it's like a stream of water coming out of a faucet and hitting the sink. It spreads in all directions at an incredible speed, sometimes more than 100 miles per hour. But what you might most likely come across is called a microburst. It means that those terrible winds are confined to an area smaller than 2.5 miles across. While speaking about tornadoes, I can't but mention volcanic tornadoes. They're possibly one of the scariest natural phenomena. When a volcano erupts, it throws hot rock and ash high into the atmosphere. As for lava pieces and hot gases, they travel down the volcano's slope. When this flow is moving down, some of the gases trapped inside begin to rise and spin at the same time. They get squeezed by the surrounding air, which makes them spin faster and faster. That's how a volcanic tornado gets born. On the bright side, this phenomenon has a very short lifespan. If you ever see a tight burning column of air, that's a fire tornado, a creepy combination of whirlwind sounds and scorching inferno. This phenomenon is also called a fire twister or fire whirl. This dangerous natural phenomenon mostly occurs during wildfires. While burning, such fires create a big area of boiling hot air just above the ground. And when this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenados can stretch hundreds of feet into the sky. Another dangerous natural phenomenon is called a snow squall. If you get caught in a snow squall while driving, you won't find a safe place on a highway, because this is an intense, but thankfully pretty short, period of heavy snowfall that comes along with powerful gusty winds, and sometimes even lightning. People have known about this phenomenon for quite some time, but the term itself, as well as the warning associated with this danger, appeared only in 2018. Another danger of snow squalls is something called a flash freeze. Come to think of it, it makes sense. Rapidly dropping temperatures and freshly fallen snow glaze highways very fast. This makes controlling your car almost impossible. The next curious phenomenon I'm going to talk about happens extremely rarely and is still poorly understood. It's usually not something big and turbulent. Dust devils can be tiny and vanish within minutes. They've got lots of names: whirlwinds, dusters, and sand spouts. Dust devils look like funnels of sand spiraling upward from the ground. But unlike their terrifying relatives, tornadoes, these babies are normally nothing to worry about. And still, according to the definition, dust devils fall in the same category as hurricanes and tornadoes. All three natural phenomena feature a column of air kind of spinning around an invisible pole. They're all formed during the collision of different types of air: moist versus dry, or hot versus cold, and so on. But hurricanes usually form over a body of water where cold air slides under warm air. Tornadoes spiral down from the sky when hot air rises through a mass of cold air, and dust devils form on the ground. Even though we call them dust devils, they can actually swirl any loose debris. The main criteria: the pieces have to be small and light enough to be lifted by a fast-moving vortex. By the way, do you know that some clouds can predict extreme weather? For example, shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft. These ominous clouds most often mean a storm is coming. Those huge white lumps over your head are called mammatus clouds. They can make you believe the sky is falling. Most clouds form when air rises into the atmosphere, but mammatus clouds appear when moist and cool air goes down and mixes with dry air. The result is these unique puffed rice clouds. By the way, if you see this phenomenon in the sky, bad weather is just around the corner. Morning glory clouds are extremely rare and harmless. They look like massive tubes stretching across the sky. They can snake for more than 600 miles, sitting relatively low. Most researchers agree that these clouds appear when an updraft squeezes through the cloud. This creates the signature rolling appearance. The cool air at the back of the cloud makes it sink downward. The best, but not the only, place to see the morning glory is Australia's Gulf of Carpentaria. If you decide to travel there to see these clouds, choose a period from late September to early November. Ever seen huge round disks in the sky? Most likely, those were lenticular clouds. They usually form over large and high places, like mountains or hills. When strong wind bumps into some barrier, this creates an air wave. The air kinda wraps around the obstacle, and the higher the barrier is, the colder the air that is rising over it becomes. At some point, the moisture it contains turns into water droplets, and they form these unusual clouds. Lenticular clouds can look like waves, a pizza, or even a stack of pancakes. And these clouds, on the contrary, form low in the sky and after some bad weather. Rainbow clouds appear on top of puffy low-altitude clouds after thunderstorms. They usually hover at the height of around 6,000 feet. When the water vapor they contain condenses, the resulting droplets act like prisms. This forms multicolored caps over the clouds. And a pretty scary bonus fact for you. One of the most common causes of wildfires is lightning from thunderstorms. But have you ever heard of a wildfire that triggered a thunderstorm? Well, now you know. It happened on May 11, 2018, not far from Amarillo, Texas. Then, the super powerful Mallard Fire not only created a massive dense cloud high in the air, but its heat also caused a violent thunderstorm that later dumped tons of quarter-sized hailstones 60 miles away in Wheeler County, Texas.